When a transverse pulse was sent from both ends of the slinky, the pulse passed through each other. Describe what happens as the pulses pass through each other's. Um, I think the pulses transferring through each other uh seem to cancel out uh each of the other waves amplitude. Uh and I think that would make the waves die down faster. How does the pulse amplitude as the pulses pass through each other contrast with the individual pulse amplitudes before and after they pass through each other? Um, I think the directions of these waves, including the sides, switched a bit, and this interference goes this interference contrasts with single pulses because the two are colliding with each other and they're sharing or switching energy. When a transverse pulse was sent from both ends of the slinky, the pulses passed through each other. Describe what happened as the pulses passed through each other. Nah, it's the same thing that happened with the transverse pulse. So I think that when they were going through to each other, I think it seemed to cancel out each of the wave's amplitude. In a How does the pulse amplitude as the pulses pass through each other contrast to the individual pulse amplitudes before and after they pass through each other? Um, it's like the same thing with the transverse pulse. I think it contrasts with the single pulses because the two were colliding and switching the energy. Contrast the amplitude of the transmitted pulse just before reflection and the amplitude of the reflected pulse. Um, I think the pulse was normal towards the reflected end, the end with the book on it, and when it reached the book, the same pulse came back and died down in a what is the phase of reflected phase relative to the original pulse? Uh, I think the pulse's energy was. I think the pulse's energy decreased once it hit the termination point. Contrast the amplitude of the transmitted pulse just before the reflection and the amplitude of the reflected pulse. I think when this Slinky was attached to the notebook, if the wave, when I saw it, I saw that the wave would come in on the left and it'd go out on the right, out of phase on the right side. So when the difference with the string was that when it was attached, when the sling was attached to the string, if the wave went in on the left, it'd go out on the left in phase, and that was the opposite of what would happen when it was attached to the notebook. Make a statement about how frequency affected the different standing waves. Um, I think the standing waves were either slow and large, either had a slow or large amplitude, or were rapid and small. Describe how waves are formed. Waves are formed by constant motion, and they and remain with the same quantity and consistency as long as the motion remains the same. So if I go the same speed and wiggle the slinky back and forth in the same like square, the wave would be created and all the waves coming out to that would be the same. Overall, what did you think of the wave properties lab? Was it worthwhile learning experience? Why not? I like this lab. I thought it was fun. I really like Slinky, so anytime I get to play with them, I think it's cool. But I think it's cool because it taught me that when like my childhood toy that I always played with and stuff like that, it was actually of use to me now, and I thought it was a worthwhile experiment. I think that other class should do it. It was cool, and it doing the waves and seeing them and watching how they start off instead of just seeing a picture and how it starts off and how it ends and seeing but being able to see the whole process. I think that was really helpful for me.